Okay, so I'm gonna get started. So today's lectures on Bitcoin IRL, wallets, mining, and more. And so in the last few weeks, we talked about how Bitcoin looks like at a high and a low level. And so we've been exploring like the main primary motivations behind what we do in Bitcoin and what we do in Bitcoin. And we also talked about how Bitcoin works under the hood all of last week. So what today's lecture is going to be about is we're going to ask the question, what about the users? How do you actually interact with the Bitcoin network, and what does that experience kind of look like? And so today we'll be talking a little bit about what Bitcoin kind of looks like in the real world and how you can get involved. So here is a quick lecture overview of what we're going to go over today. First, we'll talk about the different types of users in the space, and then we'll dive into different wallets and the mechanics that work in a wallet. And then Jillian, who's not here yet, she's going to be here in a few minutes. She's going to cover mining and what kind of mining practices are used in the real world. And we'll also explore the process of how users can actually change how the Bitcoin protocol works. So wallet types. So before I dive into what wallets are and what different types of wallets there are, I wanted to talk more about like the users in the ecosystem and the different types of users in the ecosystem. So all of last week, all of lecture 3, we talked about how Bitcoin works, but in the perspective, in the eyes of like a miner or a full node. Basically someone who mines to help secure the network or keep the network running, but then we assume that they keep an entire full blockchain, which is like 160 gigabytes of data. But like, let's say, what if I wasn't such a hardcore user? What if I was just a normal, casual person who just found Bitcoin, and I just want to test sending Bitcoins to like my friend, but I don't own like an $8,000 ASIC farm or something like that. And so we shouldn't be able to restrict these types of users just based off of if they're a miner or not. So that's why we have different types of users. We have not everyone has a powerful enough computer to mine with. Not everyone has 160 plus of free space on their computer to really store the entire blockchain. And some people just casually use the Bitcoin network and they don't have to always stay connected to the network. Maybe they send transactions like once a year or once a month. And so Bitcoin makes these distinctions between different roles that different users can take. And that's what we're going to talk about. So we have, as an example, we have like wallet nodes, miner nodes, full blockchain node, meaning that you store the full history of the ledger, and also like a routing node, which allows people to communicate in the Bitcoin network. And so this is kind of what like the Bitcoin network looks like with all the different types of users and their different specific roles. It's really messy, as you can see, but it shows like how diverse the Bitcoin network kind of is. Like different users have different like particular concentrations about what they do. And so this is just an intro to the types of users in the network, and we'll dive into wallets now. So, I mean, just before I go on any further, any questions about the different types of users? Yeah. Okay, so yeah, let's talk about wallets. So from lecture 1, we learned that identity is something super important in the Bitcoin network. Basically, all the important things that you can do on the Bitcoin network, send and receive transactions, they all rely on some sort of like identity in the Bitcoin network. And if we go one level deeper, we can see that our identity in the Bitcoin network is just a pair of public and private keys. And so these keys are really just alphanumeric strings that are really hard to memorize. So how do we actually manage like these private keys and public keys, right? And so let me ask a quick question for everyone. Where do you put your driver's license? Where do you put your Cal ID? Anybody have an answer? Your wallet, right? So in Bitcoin, we employ a very similar like concept. we use a wallet to help us keep track of our private keys, which is our identifying factor in Bitcoin, and that enables us to interact with the Bitcoin network. So Bitcoin wallets might have a few extra features, fancy features here and there, but really the main goals of a Bitcoin wallet is to keep track of private keys, store, send, and receive, and also list like the transactions that you have associated with this identity. And one thing I want to clarify is that wallets don't actually like store any Bitcoin. They're mainly a piece of software that allows you that gives you access to your private key, which can then unlock like UTXO that you can spend and receive, basically. Does that make any sense? And so wallets come in like many different forms. And so the main distinction I'll make really like right here is that there's a distinction between hot storage and cold storage. So hot really means that these wallets are connected in some capacity to the internet, and the cold storage just lives completely offline. And so let's talk a little bit about hot wallets. So hot wallets you can think of them as like web applications or smartphone applications. They're connected to the internet, and these are mainly for the convenience of the user. Some completely abstract the way of the idea of private keys or storing any sort of private key. So like users don't have to like deal with that that whole like obstacle. Some might think of it as an obstacle and they just don't want to deal with it, so they'll use these hot wallets that can abstract away all these different things. And so just an example of a few hot wallet like examples out there. So blockchain.info is like a block explorer, but they also have their own like wallet software. Coinbase has a wallet system behind their exchange, and there's these smartphone applications like Mycelium and Airbits. But let's say you don't want this like third party controlling all of your private keys and managing your identity. That's a little bit where like cold storage comes in. So these private keys are basically completely stored offline, and they're managed by you. So not by like Coinbase, not by like blockchain.info. You have complete ownership of your own keys. And so there's three main types of cold storage. There's paper wallets, hardware wallets, and then the last one is a brain wallet. So I'll get into all of those in just a bit. So let's talk about paper wallets really quick. So does anyone want to like give a quick guess what a paper wallet actually is? Yeah.
You just write down your private key.
Basically, yeah. So there's two ways. You can generate a private key and write it down physically, or you can just print it out, basically. So it's a printed version of your private key. And so there are services online that generate private keys for you and allow you to print them out. But what they state on their website basically is that if you want extra security, you might as well you should download their website offline and then generate your private key on your own, and then print it out or write it down so that it's not compromised in any way. So that's like the level of security that people have in mind when they're dealing with these types of cold storage. There's also hardware wallets. So these are like small devices that connect to your computer. The idea is that your computer can connect to the Bitcoin network and interact with the Bitcoin network, but then this like small device, or this piece of hardware, stores or manages your private keys. And whenever you need to send a transaction, what this like device does is it signs the transaction that you need to send and through the network. But these like devices never really connect to the internet. So they're completely offline. All they're used for is just managing keys, and it lets you sign transactions. And so these are pretty useful. They're very popular because of like the level of security that you get with these hardware wallets. But then all these like cold storage options are not like 100% secure. So you can always lose your paper wallet. You can lose your hardware wallet. Someone might hack into your computer and like compromise your computer. So like when you generate a paper wallet, like that's compromised too. So is there like a way to like really make a wallet that's like unhackable. And so the idea, this is where like brain wallets really come in. So one thing that you can do is just simply memorize this private key and store it in your mind somewhere. And this is like, so I just made a meme out of it. So you can use like a recommended Bitcoin wallet, or you can use a hardware wallet, or you can use a paper wallet and just write it down somewhere, or you can memorize that string, or you can memorize the QR code that's associated with that private key, or you can just store everything on Coinbase. Anyways, so how do we actually do this? How do we actually like memorizing that like really long alphanumeric string is like very difficult. So how do we actually do that? So the idea is to use a mnemonic or a collection of words and phrases to actually make that process a little bit easier. So you can memorize like 6 to 12 different words, and this will give you a way to derive your private key. So one thing you can do is after you compile like your collection of words, you can pass it through a hashing algorithm and get some arbitrary output and use that as your private key. So if you have your like mnemonic memorized, you can always derive this private key. But the idea is it's still not perfect because people aren't as random as you think. So unless you like roll a dice and pick like pages and like words from a dictionary, if you choose like a quote, a famous quote, or a line from a movie or a line from a book, the chances of you being hacked are probable actually, because all they have to do is just brute force through like a dictionary to like figure out what your like private key is. So to add like one more layer of complexity, one more layer of randomness, we can employ an idea called key stretching. So given that you have these like collection of words, the idea is to basically hash it like a large number of times until we get some sort of like final output, and you use that as your private key. So even if someone figures out what your seed phrases are, like it's like it's like something simple from a line from a movie, you have one more layer of randomness to it because they don't know how many times you ran your seed phrase through which hashing algorithm over and over again. So it just makes it more difficult to crack or compromise a private key if you're doing a brain wallet scheme. Yeah. And so there are a lot of different wallets out there, and each one has its like pros and cons. And so if you're really looking for convenience, it might be best to just use something like an online wallet like Coinbase. You don't have to deal with private keys, you don't have to deal with a lot of other things, and they might have like extra like features like multi-signature control and stuff like that. But let's say you're very concerned about security and you're willing to sacrifice your convenience for that extra layer of security. You might use software like Mycelium or like desktop wallets where you can control your own private key, so it's not in the hands of a trusted third party. And so it really depends on what you're looking for and what your needs are as a user to determine like which types of wallets you should use. And then I think any questions? Yeah.
You talk about the mnemonic phrase generating your private key.
Mm-hmm.
And then, so how does that exactly pair to a public address? I thought you generate the private public address together.
So the idea is you only need to generate a private key, and then you can derive a public key off of your private key. So once you have a private key, you can always get your public key. So the only thing that you really need to like generate on your own is the private key, and then that will be associated with a particular public key address, and then you can get like a Bitcoin address out of that too.
So as soon as you run your mnemonic phrase through a hash function, you generate a private key, and that'll always be, you can just plug that into the hash function to get a public key, to get your public address. Yeah,
basically. So like you have one way to get to your private key that you've thought of, because make any sense? Does anybody have another? Yeah.
How do you trade like Bitcoin if it's not through like an e-wallet?
You plug it directly into the code of the blockchain itself.
I'm pretty sure you can do it like that, because the types of transactions that you can send, like pay to pub key hash and stuff like that, all you really need is like certain parameters that you need to list in your transaction. It's just the wallet will simplify things a lot for you and help you facilitate that particular interaction. Otherwise, I think you would do it just manually if you really wanted to. Yeah. Okay. So we talked a lot about all the wallets that are out there, and also like what a wallet actually does. But but then how do we actually get Bitcoin, right? So so if we just like explore all the options of different like ways to get Bitcoin, there's actually like these things called Bitcoin ATMs where you can just pay using like a credit card or a debit card, and it'll actually print out a paper wallet for you, and that's very convenient. You can also like find someone like peer-to-peer, just ask them to trade. Hey, do you want to sell your Bitcoin to me for like cash or something? You can do that too. The other way is just to go to an exchange. So this is like just a list of different exchanges that are around. There's definitely a lot more now. This is from a while back, but the idea is these exchanges allow you to trade between like fiat currency and to cryptocurrency, or it can just do cryptocurrency to cryptocurrency trades. And so these Bitcoin exchanges make it easy for people who have no like access to the Bitcoin network to use like fiat currency like US dollars to enter like the Bitcoin network and ecosystem. And so you can see like Coinbases here and like Kraken, local Bitcoins also too. And so in the spirit of actually like decentralizing everything, so if we're using like a normal exchange, we've seen in the past that where centralized exchanges can go wrong. So like Mt. Gox went bankrupt because they found out a lot of their Bitcoins were stolen. And every year we hear about like scandals or like Bitcoin exchanges being hacked because of like bad practices or just because security like breaches. And so in the spirit of decentralize everything, these things called decentralized exchanges have occurred or have popped up and like gotten a lot of attention too. So we can think of the trades that happen on these decentralized exchanges as peer-to-peer. So you're matched directly with a person who will buy your like cryptocurrency or will buy your cryptocurrency using another cryptocurrency. This is usually trustless, and like just a few examples of like decentralized exchanges that are out there are like BitShares, OpenLedger, AirSwap, and EtherDelta. There's actually a lot more, but they all use like some sort of underlying new technology to actually enable this trustless and decentralized like exchange. Any questions? Yeah.
How varied are the evaluations of this?
So it really also my bad. It really depends on also the number of users you have on like your on the exchange, the volume that you're able to trade too. They're usually about the same, about like approximately the same, but they're not always like there's gaps that you can even like do arbitrage on. But the idea is that technically like the exchange rates are very similar, so it doesn't really matter where you go. If you look at like CoinMarketCap for like the exchange rate, it's actually like the average of, or it's like a weighted average of all like the top exchanges actually. So sometimes they vary a good amount in price, but in theory it's like they should be around the same. It's really dependent on like the supply and demand of like the cryptocurrency really. Any more questions? Yeah.
So exchanges like Coinbase have to get Bitcoin so that they can exchange it for fiat for people who have Bitcoins. But who sells the Bitcoins? Is it always the miners? Are they always like who's?
So, I mean, in order to even like start up to like even like come up with a exchange, you probably need some sort of pool of like Bitcoins already. So they probably started off with some amount, but the idea is because they're an exchange, they buy crypto from people, and they also sell it off to other people. So it's like a constant exchange process, or it's a constant like buying and selling process. So if you're a buyer on Coinbase, you're buying from their supply, but then whenever you need to cash out, they'll buy it back from you, basically. Yeah.
I just wanted to chime in and say there are a lot of intermediaries
Yeah.
involved. So most exchanges will have like a designated market maker
Mhm.
who has a large amount of crypto, usually a hedge fund.
Yeah,
or a bank,
Definitely,
do
yeah.
the buying and selling.
Did you have a question?
Oh yeah, do people arbitrage Bitcoin?
I think, no, it's like a definite like place of like that people do, because through different different exchanges, there's actually like a good spread in price sometimes. Like occasionally, if you're lucky, you just have to be verified on every single platform, because nowadays there's a lot of like KYC, AML like verifications for like participating in an exchange because of various reasons. Yeah, so if you're like verified on a lot of different platforms, you can probably perform arbitrage. Yeah. Okay. Oh yeah.
So it seems like if you have like a software wallet, for example, or something like you keep on your desktop, like unless you look at the code itself that like makes up the wallet, how do you know that there's not like something which sends your key to someplace else, so someone else has it in the software?
That's actually a pretty good question. I would assume that like the software is most of the time it's open source. If it's like a one that's meant for like security minded folks too, like as in like they want to store their own private keys on their own end, I feel like they would open source it, and it's basically publicly auditable, so they can see whatever like what the code does. But yeah, I mean, I can't answer the question completely because I don't actually know. But I would assume if it's open source that it's publicly auditable. If it's not, then you're in the hands of the person who created the software. Okay, so next section is on wallet mechanics. So we talked a lot about the different types of wallets that are out there and like what they actually do. But then wallet software is actually a little bit more complex, and we'll dive into a little bit about how like wallets kind of work. And so one question you might ask is, so if you're using like a wallet software, so like let's say if you're using Coinbase to like send a transaction, so the question might occur to you, why don't I have to download the entire Bitcoin blockchain if I'm using this wallet software basically? And so the idea is we have SPV to really thank for that. So SPV stands for Simple Payment Verification. And this is a method of verifying or like just confirming transactions if a transaction is included in a block. But the caveat is that instead of actually downloading the entire block itself with all the transactions, all you download is like the block header, which is compact and it's finite. And the way that so yeah, this is a very like space efficient way to verify or confirm transactions actually, and it's useful for like these wallet software like providers to really leverage this technology so that they don't have to download like aspects of the blockchain directly onto like your phone. Let's say your phone doesn't have that much space, so why would you want to download like 160 gigs? So it's useful for clients who can't store an entire blockchain. So if you're using a wallet app and all you really need in this wallet application, and so now if you take away that like storing the entire blockchain aspect, all you really need is the key management aspect, which a wallet should handle, and also the networking aspect of communicating to other nodes in the blockchain. And so how do we actually do that? So this is all possible because of if we recall from the previous lecture, we have this idea of the Merkel proof of inclusion. So all we have to do is query specific aspects of the blockchain from other nodes in the network, and then we can reliably guarantee that a transaction is included in this block. And so, but one major like assumption that we have to make is that all the block headers that we're receiving aren't like false, aren't like forged in any way, because if someone is feeding you bad block headers, there's a chance that they could double spend against you. And to prevent this, what you want to do is you want to be like as connected to your peers as much as possible, so you can compare and contrast like block headers that you receive from all your like neighbors, basically. So you have if you have one differing block header and everyone else gives you a different one, you can determine that you can lower the risk that you're receiving false block headers. And so this is very important because then it reduces the chance that you'll get double spended on, and also you'll be able to like confirm transactions and verify transactions in a relatively space efficient way. And so this is a really good trade-off if you just can't store all of this blockchain info and you're just like on your phone verifying transactions. And then so the next thing I want to talk about is multi-signature transactions. So we briefly covered this in the last lecture, where we talked about in Bitcoin script we can denote like a multi-signature transaction. So one thing that wallet software some wallet software have implemented is the idea of being able to send these types of transactions through just the wallet software. And so this idea allows for like n total people signing off on a transaction to actually allow it to authenticate. In simple terms, multi-signature is a way of cryptographically kind of sharing keys between different participants, and it also serves as a way to distribute points of failure. So I'll talk about that really quick. So let's say Jillian, Nadir, and Gloria are trying to send a transaction to me. This scheme of, let's say it's like you need 2 of 3 people to really authenticate a transaction. So if any one of these members in the party kind of like want to run off with their key and try to spend all their Bitcoin, they can't because they have 1 of the 3 keys. So the other 2 can perform a transaction and unlock this and unlock and authenticate this transaction going through, and then this will be broadcasted to the network and it'll send me some Bitcoin. So that's one example why multi-signature is useful. Another idea is, let's say Jillian just wants to be extra secure, and so she'll set up a multi-signature like wallet with herself, just herself. So it can be like she has 2 computers and her phone. And let's say one day she loses her phone with her private key on it. Even though she loses her phone, she can still use her 2 computers to unlock this wallet and send her funds to someone else. So like in the case that she only had 1 public key and she lost her phone that contained the private key, then all her funds would be lost. But in this case, because she can still recover 2 of the 3 private keys that she's holding, she can send a transaction in that case. And then a third example is if a company it allows for multi-signature transactions, you can do something along the lines as this company stores like one aspect of your private key for you. So yeah, so they store one part of the private key for you, and if they were to run off with it, they still wouldn't be able to spend your particular Bitcoins. If Jillian or Rusty kind of lose, if one of them lose their like private keys, then they can work together with the company to like recover a new account per se. So this is useful for a lot of different like scenarios, and so that's why multi-signature is actually really, really cool. Yeah. Okay. Any questions before I move on? Okay. So in general, it's actually best practice to really never reuse pseudonyms or identities that you've interacted with on the Bitcoin network. And what I mean by that is to actually enable that, you have to generate a new public key and private key pair every time you make a transaction. That's just considered best practice. And so why do we actually want to do this? One, it makes it more difficult to determine someone's balance of Bitcoin. Also, their spending history. You don't want to be able to like look into, oh, this person spent Bitcoins in like these different addresses. And also because keys are really easy to generate, so why not try to generate a new key every single time? And so usually wallet software handles this for you. And so like you as a user really don't have to think about it. And so how do we actually manage this? So in the past, they used something called a JBlock wallet, which is just a bunch of keys. So basically, every single time you make a transaction, you'll generate a new key pair, and then you'll just continually do that. Or you can just start off by generating a large number of them, and then just use them up as you go. But it's not very convenient because you have to store basically all your key pairs, and that's potentially difficult and inefficient to work with. So they came up with a very clever solution called HD wallets, which is hierarchical deterministic wallets. And so the key idea behind this is, can we make a scheme where we can actually create wallets from this master seed or master key? And so one way why this is useful is, in the previous example, if we're dealing with just a bunch of keys, if you're an exchange managing large number of transactions and a large number of users, that's a lot of private key, public key pairs to really keep track of. HD wallets simplify a lot of this because it allows a way to like generate a key deterministically every single time, so that you can generate a key deterministically every single time. So you don't actually have to store the keys. You can just generate them as on the fly, basically. And so what this actually looks like is you start off with a master key, which will create a master seed, which will create a master key. And so what you can do is you can define any number of children keys that you want to create. So using this master key, you can hash it and create a new key, and you can create an arbitrary number of those. And so as like a master key, you can always find what your child keys are. And then the other caveat is that as a child key, you can also use that as a parent to generate more and more keys. So it's like a hierarchy of different keys, and the keys that you have on as a master, you can always access downstream all your different keys there. But then as like a child key on the very, very bottom, you won't be able to access keys before you because you won't be able to reverse like some sort of hash function. Yeah.
But if you have access to the master seed or master node, you have access to that.
Basically, yes. So the idea here is, if you think about an example of like a company, right? If you have a president that's holding all the fund, like that can access all the funds in the company, he can also designate like department heads to actually control a particular department's funds, but then this president can spend all of that, any department's funds, and then equally so, each department head can allocate keys for its employees, and each one can like further allocate downwards. And so this is actually really, really useful, because now you don't have to store just keys by themselves. You can always incrementally like figure out where or how to get to a particular key, basically. And this is really powerful. Any questions? This is a little bit confusing, but if you understand this, this is really, really cool. No more questions? And then we'll dive into mining with Jillian.
Okay, hi, I'm Jillian. You probably haven't seen me yet, but I'm here. So mining. Does anybody remember what mining is? Hopefully. Cool. Thumbs up if you remember what mining is. Solid. That's a good percentage of the class. Not as high as I'd like, but okay. So mining review. So a full-fledged Bitcoin miner has to have these things. Just a quick review. They have to download the entire Bitcoin blockchain. Can someone tell me why that might be? No one knows why you have to download the Bitcoin blockchain? Okay. Oh yeah, go for it.
You need a history of all the past transactions
Exactly.
to add on to.
Exactly. So how are you going to check whether or not somebody has the right amount of money, some public address has the right amount of money, if you don't have the entire Bitcoin blockchain to go through? You got to reconstruct what they did. We got to verify incoming transactions. We got to create a block, whatever that means, and then we have to find a valid nonce to make that a valid block. And then we broadcast our block, and we hope that everybody accepts our block, and hopefully we get to profit. Okay. Anybody have questions about this? Go for it.
We have to solve the puzzle too.
Yeah. So they have to solve the puzzle, which is finding a valid nonce. Solid. Okay. So we're going to talk about each of those. So step 1, or step 0, because we're 0 indexing, you get blocks from your peers. So you're going to want to download the entire blockchain, like we said, and you want to get that from all the way starting at the very beginning. So beginning being the Genesis block. That's just what we call the very first block. And you want to make sure that you stay up to date. So what we say in blockchain is you have the longest blockchain is our most recent version of the truth. And so you want to make sure that you're really keeping up to date, because if you're just doing your own thing and not making sure you're collecting blocks as they might pop up, you're not going to be building blocks off of the longest chain. You're not going to get paid. Your blocks aren't going to get accepted by other people. Does anybody have questions about that? Okay, go for it. Is that a hand? Oh, sorry. Okay. So no questions. So second step is to verify transactions. So we're going to listen to the Bitcoin network, looking for transactions, unconfirmed transactions. So that's just anybody who sends a transaction. If I go to the coffee shop and I'm like, I want to buy a coffee with my Bitcoin for some reason, I'm going to send a transaction. Somebody needs to confirm it and put it into a block. That's the miner's job. And so until then, my unconfirmed transaction is sitting in something called a mempool, which is just like sort of a pool of all the unconfirmed transactions. Anybody have questions about that? Yeah.
Where's the mempool stored?
That's a good question. So that's something that if you're a miner and you're verifying transactions, the protocol just sort of like takes it in, and it's up to the miner to decide which of them they want to accept. So we'll talk about that a little bit later, but basically you're going to ping all the nodes you're connected to and be like, hey, do you have any new transactions? I'm going to just collect all of them, and the protocol just takes care of like holding it on to you free. Okay. Any other questions? That was good. Yeah.
So if your transaction is false and you drink the whole coffee, you tender it out.
Yeah, so the person selling the coffee needs to wait until they're very sure that they got their Bitcoin, right? Which is 10 minutes. Or 20 minutes, or it is up to the person who's selling the coffee on how long they want to wait, so how confident they can be that the block will get saved and will get accepted by everybody.
So that was 6 blocks.
Yeah, so 6 blocks, so yeah, an hour, sorry. Yeah, okay. Any other questions? Yeah.
In banks, like there's the same delay with like traditional banks.
Sure.
If you use credit card to buy coffee, like it's not instantly, the money's
Sure.
not instantly in their hands.
Sure, but that's a different concept, right? That's credit, or debit where it's faster. But credit being that the bank trusts you to do that versus there's nothing backing you up on the blockchain. Does that make sense? Okay. All right. So we keep going. So then creating a block. So if you remember from last lecture, you take the Merkel root, which is basically the hashes of all the transactions that are going into this block, and you take the previous block hash so that it can be linked to the last block, and you take a block header, and this is basically the important stuff that you guys need to know about going into a block. Any questions about this? Should be reviewed. Okay, then finding a valid nonce. This becomes the proof of work part of Bitcoin, where you need to expend computational power. You need to change that green colored nonce in order to hit some target. And so you're just going to be like brute forcing, changing the nonce in order to make the hash of the whole header fit some desired puzzle. Does that make sense to people? Do you have questions? Yes.
The previous slide. It says that you can choose whichever transactions you want to put in the block as a miner.
Yeah.
And I'm assuming you do based on most
Yeah.
transaction fees. So what if you have like a transaction with like low fees and just get like stored in that?
So we're going to talk about that later. Yeah. But yes, essentially. Okay. Okay. Any questions about this slide? Yeah.
Why is it necessary to expend computational power in order to be able to add a block?
Okay. This goes back to something that we covered in a previous lecture. Would you mind, like, if we talked about that after class? Okay, sounds good. Okay, so if we keep going. And then for the fourth one, this is broadcasting. So let's say I've expended all this power, I've created a valid block. Now I want as many people to know about my valid block as possible, as quickly as possible. Because if I don't get it out there and another block is released, and they like sort of let the rest of the network know faster than I do, then their block becomes accepted. If the majority of the network accepts that their block, then my block is rendered void. Does that make sense to everybody? Because we're based off of the same most recent block, presumably. And so they take the majority. Okay.
Is there,
Yeah.
Is there any kind of protocol about how one receives the broadcast? I mean, like.
Yeah, so that's
do you have
built into the, I'm sorry?
Do you have preferential receiving based upon something?
That's not supposed to be, like, you're not supposed to be having preference in what you receive. If there's a percentage of the network that is working together to block certain blocks, that gets into different kinds of attacks that we'll get into in a different lecture. But generally, you're not supposed to be able to, like, block or censor certain blocks from certain addresses, if that makes sense. Does that answer your question?
Yeah, I'm just worried. I'm interested about the protocol.
Gotcha. Yeah, we can talk about that after. Yeah. Okay. Okay, so just trying to get through this part. Yeah, so and then remember that mining is a competition. So the block included in the longest chain, that's going to become the newest valid block. That's the newest state of truth. And the profit that you get from mining that block, which is something called the block reward, which we'll talk about in a little bit, the profit that you get from that is only valid if your block is accepted as the one that everybody sort of picks up on. And so that's why you want to get your block out there as quickly as possible. You want everybody to pick up on your block so that they start building off of your block. And then that makes your block the most recent. Again, anybody have questions with this concept? Okay. Yeah, okay.
So in occasions where you do not get your block out there fast enough
Yeah.
for some reason, and it gets void, does that mean you have to recompute again in order to broadcast this transaction?
Exactly. So your Bitcoin, on the Bitcoin network, that's exactly what happens. You sort of wasted all of that work and you have to start working from this new most recent block because otherwise you're not going to be able to outcompete the network. Yeah.
Once once a transaction is included in the block, does it automatically get purged from mempool?
Yeah.
So
So it gets purged from your mempool, but it doesn't get purged from every person's mempool unless it becomes like accepted by everybody. Does that make sense?
Yeah.
So as you accept a new block as like the new state, most recent state, you might take that out of your mempool. Okay. All right, so we got a lot of questions, so I'm going to skip this slide. If you have more questions about that, you can let me know. But mining incentives. So now we're going to talk about why it is that people want to mine. That's a lot of storage that you're holding on your computer. You have to download the entire Bitcoin blockchain, which is not insignificant. It's been around a while, so there's a lot of history. So why do we do things? So in a rational environment, go back to economics, people do things because of profit. And that's sort of why, that's what the Bitcoin sort of ecosystem is based off of, is getting people to do things for the right reasons. And usually profit is a good way to get people to do what you want them to do. So if we go back to what profit means, profit is just revenue minus cost. And if the revenue is greater than your cost, you make some money. And so you want to maximize your revenue and minimize your costs. And so if we look at these two equations, your mining revenue is going to be comprised of something called block reward and transaction fees. Your mining cost is going to be comprised of fixed costs and variable costs. So we're going to talk about each of those in separate. So first, block reward. So every time a miner builds a valid block, remember, that requires them to solve the puzzle, put all of these transactions into their block, and then after validating all those transactions, then solve a puzzle on top of that block. And then if they manage to do that correctly, and they manage to get everybody to accept their block, they win something called a block reward. That's something that's included in their block as they propagate it, and there's just something built into the protocol that rewards the miner for having done all this work. So currently, that's 12.5 Bitcoin, which if you're following how much the price of Bitcoin, at the peak of Bitcoin, that was quite a lot of money. Still quite a lot of money, but the miner gets that sort of special treatment because they went through all of this work. And so the block reward is something that halves every 210K blocks, because there's a finite supply of Bitcoin. So it halves every 210K blocks. You can do the math. The next time it's due to halve is in 2020 May. So if anybody's a junior, around when you'd be graduating. And so you can do the math. Like the next time it halves, the block reward will only be like 6.25. I can do math. 6.25, and it'll keep halving. And so eventually that block reward will go to 0. And we'll talk about what happens when we get there. But again, so Bitcoin supply cap, it's capped. This is a currency that's deflationary. So it's capped at 21 million Bitcoin. There will only ever be 21 million Bitcoin. Okay, any questions about this slide? Solid.
Does it just stop at 0, or does it just keep halving until?
So the smallest you can have is a Satoshi. So once you hit something like that, like we're not going to keep breaking it. Does that make sense?
What's a Satoshi?
Is so if you divide a Bitcoin, you can divide a Bitcoin some more. I'm sorry. 10 to the negative 6. Yeah. Cool. All right. Okay. Any other questions? Yes, really quickly.
Transactions only that are decentralizing the miners?
Yeah, exactly. So that's what we're going to talk about. So, well, not quite, but next slide. So mining incentives. Let's skip this slide. Okay, so if we talk about transaction fees, this is the more important one. So transaction fees, when the amount of block reward eventually drops to 0, this is the other part that's really going to come into play, and this is what people talk about, perhaps saving the Bitcoin ecosystem whenever we hit that point, which is far in the future, but it's worth considering. So the transaction creator sets this transaction fee. So say I'm creating a transaction, it's really urgent, so I'm going to attach a very large transaction fee, and as a miner, I'm I want to take the most reward as possible, so I'm going to pick the transactions that give me the most profit. So I'm going to pick a transaction that has a higher transaction fee. And so it's extra income for miners on top of the block reward. They can earn quite a lot of money from this. And the higher transaction fee, the less time you have to wait for your transaction to sit in the mempool. Makes sense. Okay, any questions about that? Okay, sounds good. All right, so then we'll move on to mining costs. So there are some fixed costs when it comes to mining. Does anybody have any ideas what might fixed costs mean? Yeah, go for it. Electricity. Okay. Anything else?
Cost of a Bitcoin miner?
Cost of a Bitcoin miner. That's valid. Yeah.
Yeah, isn't that ASICs, right?
ASICs. Yeah, ASICs are one kind of one kind of hardware that you can use to mine Bitcoin. They're very good at that. Okay, so let's talk about fixed costs. So one fixed cost is hardware. So CPUs, so if you look at this graph over here, the CPU era for when people use CPUs to mine Bitcoin was back in 2009. So 2009 to 2010. It wasn't a very long period, but back then, because there weren't a whole lot of people on the network, it was totally viable to be mining on your MacBook, for instance, or your whatever computer you have. But that didn't last very long, because as people picked up to the fact that they could create, as it seemed back then, you could create magic money, magic internet money with your computer. It became more and more popular, and people started finding that they could do this in better ways. So GPUs, does anybody know what a GPU is? What does it stand for? Graphical processing unit. Okay, so GPUs are really good at linear algebra calculations, some very complex like math. They're just optimized for that because that's what sort of graphics need. And so people found that GPUs are really, really good at doing similar calculations. And so you had this whole era where people were just buying GPUs and trying to mine Bitcoin. And then you had this section where you had FPGAs, where, so we'll talk about each of these, but just sort of an introduction, you see that the hardware got more and more complicated as people found they could make money with it. All right. So with CPUs, the main takeaway from this slide, I think, is to think about the fact that hardware costs are fixed. So unlike what we said earlier with electricity, electricity is one of the costs that are actually variable, just because the cost of electricity changes. Okay, cool. Anyway, so CPUs were the first, right? They were relatively straightforward. Didn't need a whole lot of complex code to make your CPU a little bit optimized for mining Bitcoin. And then GPUs consumed more energy because they were dedicated units, but they did the work faster. The disadvantage being that GPUs weren't built specifically for mining Bitcoin, so there's a lot of stuff on there that mining Bitcoin doesn't make use of, and it's not meant. So GPUs weren't designed to be run in large mining farms, which is what people started doing, and so they ran into problems with that because again, GPUs they overheat if you try to do too much with them, stuff like that. So then people came out using FPGA arrays, and this was really the beginning of using Bitcoin-specific hardware to mine Bitcoin. And again, each of these hardware iterations becomes more and more expensive because people spend more money and more energy and more time and more manpower designing these dedicated hardware circuits. And the question becomes, when is it worth it for me to invest in dedicated hardware? And so as the price of Bitcoin is still continuing to survive, then maybe it's worth it. But if Bitcoin crashes, it becomes less worth it, etc. So some things to consider. And then ASICs. ASICs are just perhaps the most dedicated of them all. ASICs are just very, very good at that. And again, it's just another iteration. And most of the things you hear about nowadays, people mine with ASICs because you really can't keep up with the ASICs out there if you're just mining on your computer. Okay, any questions about these? Yeah.
What is time to block?
Time to block? Where does it say that?
The second column.
That means how long it takes for you to find a block, a valid block with this sort of computing power.
It takes 10 years to do that?
Yeah.
On average.
On average. And it's not 10, and that's not 11 anymore. If you bought one maybe 2 years ago, it's already outdated, so you still have to keep buying new hardware every year, which makes it really unfortunate. I think right now, so for example, it might be possible to mine a Bitcoin with an ASIC in 11 years. That means that comparatively on your computer, it might take 34 years, something ridiculous, right? Yeah. Anyway, okay, so if we keep going, so those were fixed costs. We talk about variable costs, so that, again, things to think about are electricity, the cooling, so if that's water cooling, if that's fans, if it's more electricity, if it's, and then it's manpower, so the amount of energy, people hire firms to design, you hire very specialized computer scientists to design hardware specifically for this. So all of this is a lot of time and energy put into it, and these are all what you could consider operating costs or variable costs. Are there any questions about this? Yeah.
Is there any mining going on
Here in Berkeley?
here?
Not of Bitcoin. Well, not that I know of, not of Bitcoin. But perhaps of other cryptocurrencies. Generally, the dorms are a pretty popular way to get free electricity. I didn't say that. So this section on the bottom here about the data furnace. So a fun aside is the fact that mining a lot of Bitcoin or having all of these things, as it generates a lot of heat, so one thought has been, instead of using all this energy to cool it and running water through it and everything to cool it, you might as well reroute that energy and use it to power your house or power a swimming pool in a hotel without telling the hotel, for instance. So there have been sort of interesting applications of that. Potentially, if you're interested, you can go read about that. Yeah, anyway. Any questions? All right. Okay. So we should talk about real-world mining because this is just theoretically how we think mining should work. This is like the process people go through to create a block, etc. But how exactly do ASICs influence how Bitcoin has evolved over the years? So this is a Chinese ASIC mining farm. You can see that like the setups really range. They can be pretty bare bones, like on the left, but they can also be like very high tech, like on the right. Generally, as you know, we're trying to minimize costs, and so people will go to places that have like really cheap electricity, for instance, which is why places in Russia or China have been traditionally a little bit more popular. And that's not making a political statement. That's just like sort of the things that show up on Reddit and stuff like that. That's sort of the trends of what people believe. And yeah, so as you can see, these are sort of like these are what are called mining farms. You just have like lots and lots and lots of ASICs just next to each other. Any questions about this? It's just a picture. Cool. Yeah, and so these are some examples of ASICs. If you know more about hardware, you can come talk to Brian after this, because I don't know much about hardware. Okay, so if we talk about mining pools, so mining pools are this idea that together we are stronger. So if individual miners are having a huge problem, like getting the capital to mine a lot of Bitcoin, but I still want to contribute, or I just have like one ant miner, or I even have my laptop, but I still want to participate, I can join a mining pool so that I pool together my computational power and I can contribute a little bit and perhaps get like a fraction of the reward. And so for a miner, this reduces variance and mining rewards because I'm guaranteed to get some sort of payout given that I do some work, etc. And there are different strategies that we'll go over for how a mining pool might operate. But generally what you can think about is the fact that it's run by pool managers. So this introduces some centralization where a pool operator manages like how we divide up the work among the members of the pool, stuff like that, and then the pool manager will take like a small cut or like a large cut. So over here on the right, you can see all the different mining pools that we know of. So this is projected, what we think, how big we think each of these mining pools are. There's actually like not really a good way to know. These are just estimates. And so one interesting thing to note is we recognize that Bitcoin is 51% attack vulnerable. So if we have a malicious person owning 51% of the network, for example, a large mining pool, we lose confidence in Bitcoin. And so for this reason alone, one of the larger mining pools a few years back they were starting to get really large, and they actually split up and said, okay, like we recognize everyone's getting nervous because we're too large, but we're going to step back and we're going to split up because it's in everyone's best interest that we do, and we'd like to keep the price of Bitcoin alive. Does that make sense? Okay, cool. All right. So the way sort of mining pools work is miners in a pool can submit shares. So shares are something like, imagine if I solved the block and I like had tried all of these different numbers between 0 and 100, and I said, I've tried all of these, they don't work. Let me just send my progress to the pool manager. And the pool manager looks at it and is like, okay, yeah, that looks valid. I'm going to pay you for, I'm going to pay you at some point, like, for the computational power that you've expended. And how I pay you will be discussed in, like, how we, like, whatever payment structure we have inside our mining pool. But essentially, the idea is that as an individual, I can do part of the work and still get paid for that. Okay. And the obvious question that should follow from that is, as an individual, why can't I, like, what if I, between my 0 and 100 small, tiny fraction of all the things that I'm supposed to be trying, I find a valid block. So if I find a valid, like, I found the solution to the puzzle, I still can't just, like, submit it to the network and be like, laha, look, I found the block, it's mine. You can't do that because the puzzle that you were solving, like, has the Coinbase nonce of the pool manager. And so the puzzle that they gave you, like, even if you send it to the network, it's automatically going to pay out to the pool manager. Does that make sense to everybody? You're set up in such a way that, like, the puzzle that you're solving is going to pay out to the entire mining pool. Anybody confused about that? Sounds good. Okay. Okay, so these are two mining pool schemes. The first, pay per share, the idea is that for every share that you submit, remember a share is a near valid block, so part of the puzzle that you solved. So if you submit that, pay per share will say, okay, I'll pay you per like whatever share you gave me. Pay per proportional is the idea that after a valid block has been found, like it doesn't matter who in the group found it, after the block has been found, the pool manager will go back and tally up, okay, so this is the fraction of work that this person did, and this is the fraction of work that this other person did. Let me divvy up the rewards that way. And so do people understand the difference between these two? On the left-hand side, pay per share is sort of better for the miners because they get the reward immediately, versus proportional, where you have to wait for the whole mining pool as a whole to hit upon some reward, and then you get your payout. Furthermore, pay per share is not so good for the mining pool because he sort of has to pay out in advance. He says, yeah, let me just like pay you for whatever you submitted. It might be that we haven't found the mining reward, we haven't like created a valid block yet, but I'm just going to pay out in advance because that's what we have agreed upon. In this proportional one, he doesn't have to do that. He just pays you whenever he gets the money. Make sense? Okay. So these are some other reward schemes. If you're interested, you can take a look. We aren't going to go into them today. So some mining pools, mining pool pros and cons. So the pros are that as an individual miner, even if you don't have a lot of computational power, you can participate. And it's easy to, if everybody's in a mining pool, it makes it really easy to upgrade software changes, which means if a mining pool director, like a mining pool manager, decides we're going to ratify to this software upgrade, then everyone who's in that mining pool sort of has to agree to that, to be in that mining pool. So it makes it really easy for people to like work together because they have an incentive to. And then the cons are that the pool manager has to be trusted. So what happens if the pool manager runs away with your block reward? What you're going to do? So the pool manager, again, is a form of centralizing the blockchain network, or the Bitcoin network, which is unfortunate. But this is sort of the natural direction that sort of the ecosystem has taken us. So does anybody have any questions about these? Yeah?
What would happen if theoretically that one pool dominated all of mining?
Yeah, so that comes back to the example I was talking about earlier, where one pool almost, like very nearly almost had like 51% of the network, and people started like getting worried and like posting about it, talking about it. And in that scenario, they sort of stepped back and they owned it, and they made a public statement that said, look, we're splitting up. We're gonna, from now on, we're gonna be known as like these two different, or like these three different entities. And we're splitting up for the good of the Bitcoin and network, because we recognize that if one mining pool owns too much of the mining power, it's bad for everybody, right? The Bitcoin value will drop.
Yeah, but why is it bad?
Because what's the problem if somebody owns 51% of the network? Does anybody know the answer? Yeah.
They can have free reign over what's written on the blockchain.
Exactly. They have free reign over what's written in the blockchain. Does that make sense? Somebody else want to elaborate?
Like they essentially have infinite money, and then when they have infinite money, like the value of blockchain just goes to zero, and everyone loses.
So perhaps another way to phrase that is, if I have 51% of the network, nobody is stopping me from sending out transactions and then confirming them automatically because I have 51% of the network. I can agree with myself and then send them back. Does that make sense? Okay. Did you have a question?
Yeah. So what's to stop one person from being part of all these mining pools and eventually, you know, they theoretically could have 51% of the network and you never know.
Yeah. Yeah, so that's something we're going to talk about, I think, next slide. Yeah, so it's the idea that a single entity might be participating in multiple pools. So this is one sort of attack. You actually don't know whether like one mining pool is sending sort of part of their computing power to pretend like they're in a different mining pool, but really they're working together. We really have no idea whether that's happening. And we look at this, and this is really just an estimate. And so we have to sort of trust that this is what's happening, that this is like what's good for the Bitcoin network, and that people are altruistic enough to stand back, which might seem like a weak excuse, but again, like this has happened in the past, and people have actually come up and like decided they were going to split off, and given like sort of tangible evidence they've split off. So yeah, but again, actual concentration of control over the mining hardware is pretty unknown. Something that's kind of interesting to note is if I'm a company that makes a lot of ASICs, it like sort of stands to reason that I would also lead a mining operation and perhaps be a mining operator. And so that's something that a lot of people have speculated about, sort of linking different mining corporations, like companies that create ASICs to mining operators and stuff like that. Yeah, a question? You had a question?
So a 51% attack, like that only enables you to double spend, right? Or does it enable you to like just create infinite? Because don't you still need to authenticate?
I think Brian wants to answer.
So I think one way you can think about it is once you have like 51% or more, so you have a majority stake in the network, you can basically fork off and create your own just you being the only participant. And in that case, like you can basically do whatever you want. You can censor people's transactions. I mean, you're the only person in that network now, so you can just create a version of the blockchain that's stronger because you have more computing power. You can always outpace everyone else. You can just get more money for yourself. Scenario. You can also, if you have other people in the network that you're considering, you can also censor the transactions too. And there's a lot of other bad things that can happen once you hit 51%. Because in theory, like that's when you have majority, you can just fork off and get your own version of the blockchain that you're using.
Okay, so unless there's like one other quick question, okay, then let's. Okay, maybe we like wait until discussion for that. Just trying to push through to the end here. So here's some quick facts about mining pools. We published slides, right? Yeah, so I'm just gonna leave this here. You can take a look at it later if you're interested. These are just some like interesting facts. So yeah, I'm gonna skip past that because we don't have time. Yeah, so we're talking about decentralizing mining. We really like. Remember, Satoshi's original dream was to have one CPU, one vote. That's the whole point of having this proof of work where like we tie computational power, et cetera, et cetera. So because one CPU, one vote isn't like real in the real world, unfortunately, because of ASICs and mining pools and mining farms, we'd like to find a way to like decentralize mining. Yeah? Everybody understand the problem statement? Okay. Yeah, so if we think about what's required from a puzzle, again, this is slightly different from maybe a slide that you saw in a previous lecture. We've added a few that we just implicitly talked about. So a puzzle has to be quick to verify. It needs to have adjustable difficulty for this particular scenario because we want the Bitcoin network to be able to publish a block like every, anybody know? Every how many minutes? Yeah, okay, every 10 minutes. And so in order to confirm that, in order to make sure that we have a block coming out every 10 minutes, even though the computing power varies, we have to be able to adjust the difficulty of the puzzle. It has to be computationally difficult, so we can say that somebody expended some amount of energy, and the solving rate has to be proportional to computational power. So if I put in more computational power, I need to be able to solve it like more quickly, faster, etc., more often. And then progress-free, meaning that if I was working on a block and then somebody else came out with a block, if I start working on a different block, I don't have like any information about what this block might be just because I was working on a previous block. And it has to be pseudo-randomly generated. So I can't have like a centralized person generating these puzzles because that defeats the purpose of decentralization. So a quick reminder, Bitcoin's puzzle is a partial hash pre-image puzzle. So you can ignore all of those words and just remember that really we're looking for some hash that follows some prerequisite number of zeros. I'm just plugging in like numbers into a formula and hoping to see what I get out on the end is led by some number of zeros. Okay, so two things that we can do to sort of combat ASICs. Remember, ASICs are really, really good at doing computation. So if we instead don't tie it to computation and we instead tie it to memory, ASICs are by definition not so good at that. So if we define something called memory hard, where a memory hard puzzle is something that requires a large amount of memory instead of computational power, ASICs will sort of run into this memory bound problem where they don't have enough memory, they sort of fail on these sort of problems, and voila, you have a a memory hard puzzle that's ASIC resistant. So as you can see, there has been evidence that memory hard puzzles deter ASICs. ASICs, again, are optimized for specific calculations, and they're not so good if memory is the limiting agent. Of course, does anybody have questions about the slide?
Does anyone use memory hard puzzles? What coins or?
Yeah, so people have tried this, so which is what we're going to talk about. Any other questions? Cool. All right, so this is scrypt, which is a hash function that is meant to be memory hard. It's meant to be ASIC resistant. So some very smart people got together, designed sort of this algorithm that would be difficult to, not an algorithm, but like the sort of hash function that would be very difficult for ASICs to compute against. And even though Dogecoin was created as sort of a meme coin, they use scrypt, which is cool. They're ASIC resistant. And again, so this is difficult to brute force. Yeah, okay. Anybody have questions about scrypt? Memory hard, cool. So the main idea behind scrypt is if I fill an array with just like a lot of like random numbers, and my puzzle to you to test whether or not you're saving this array is I ask for like index 5 and index 7, and I just like randomly generate which indices I ask for. If you can reliably tell me what like things are saved there, then there's a pretty good probability that you're actually saving that amount of like memory. Does that make sense? So we just change the puzzle, we change the constraints, and we make it so that you have to save all of this. Yeah, and so ASIC developed. So the problem being that ASIC changed, then they figured out how to make an ASIC for this. Right? They found an ASIC that was really good at memory, because that's just how like the market works. And so we can take this as a lesson, sort of. It's used by, so scrypt was sort of a precursor, and then we have X11 or X13, and this is just like a variation on this sort of memory-bound, memory-hard puzzle. And if you've heard of a cryptocurrency called Dash, there's a lot of hype around Dash precisely because everyone was like, oh my god, it's ASIC resisted, it's so cool. And so everyone was excited about Dash, and then they came out with an ASIC for Dash. Yes, and so over here on the right, you can see like this graphic is of some people who came out, some very smart people who came out with an ASIC for Dash. And so down there in the corner, you can see there's a quote that says, there's a Bitcoin Core developer that's saying, like, there's really no such thing as an ASIC-resistant algorithm. The point is really, like, the takeaway here is, if you create a market for something, somebody will find a way to do it. The question is, like, how you can maybe work around that. And so Dash was doing this thing where like they were periodically switching mining puzzles and making it difficult. Like if you're buying up a lot of ASICs of one particular kind, if they switch up the mining puzzle on you, it's really costly for you to then buy a whole bunch of other mining equipment. And so not everybody has the capital to do that. Stuff like that. They were trying to like find all different kinds of ways, but again, the takeaway is ASIC resistance is difficult, so it's potentially something that like you guys should think about. So pros of ASIC resistance is that ASICs dominate the network and suppress the regular people, which is not worded in a way that sounds like a pro, but it increases democracy and decreases centralization because if your average person can buy an ASIC, then you can still participate in this network. The cons being that ASICs can only solve a puzzle, and then other than that, they're pretty useless pieces of hardware. Again, if the Bitcoin price tanked, all those ASICs would suddenly become just like has-been hardware that was like once really, really expensive to buy, but now has lost its worth. Okay. Any questions about this? All right. So one last sort of interesting aside. So if potentially you have thought about like how proof of work is like pretty stupid. It's just like proposing a question and then like you have to brute force the answer. So some people thought about this and were like, why don't we make use of all this computing power? And we'll call it proof of useful work, and we'll have people solve all of these interesting problems, searching for large primes, which is a very difficult problem, finding aliens, like going through, which requires a lot of computational power because you're processing a lot of like information, simulating proteins at an atomic level, generating predictive climate models. These are all things that like humans haven't really figured out how to do yet, so we just brute force them. And this is like potentially a good application, except for the problem that most distributed computing problems, of which those were some examples, they're unsuitable for proof of work precisely because of these reasons. So there's a fixed amount of data, which means that we don't have an inexhaustible puzzle space, which means that if I were to build a cryptocurrency on that and say my puzzle is to look for aliens, at some point we're going to run out of data. And what happens then? My cryptocurrency just like, what do we do? I don't know. And so because of this inexhaustible puzzle space requirement, it becomes difficult to do things like proof of useful work. Another reason is potential solutions are not equally likely. So if you think about modeling proteins, there are some sort of iterations that are more likely than others, which means that we don't have that requirement that if you think back to what we require from a puzzle, we need all solutions to be equally probable so that everybody has an equal chance of finding a solution, which, again, this is not necessarily an example of. And then finally, we have to rely on a central entity to delegate tasks. Presumably, you would rely on, like, NASA to give you space data. There's probably a better way to say that. But they would give you some sort of data, and you would parse through that to find aliens. That was a really ridiculous statement. Okay, but you understand why. Like, this is introducing sort of a centralized component, which makes it really difficult to run a decentralized system on. Okay, so in summary, proof of useful work, unfortunately, doesn't work, even though it sounds like a really great idea. Anybody have questions about this? Cool. Okay, and then just really quickly, to set us up for next week, we are going to talk a little bit about how exactly we make updates to the Bitcoin protocol. So Bitcoin Core, anybody know what Bitcoin Core is? They're just a team of developers who were like really passionate about Bitcoin, and they've been contributing to this open source software for a long time. They get sort of voted into those positions, and they're a team of developers who sort of manage and update the Bitcoin GitHub repository, and the software is designed by these developers. They have like full Bitcoin nodes, stuff like that. They're sort of like the go-to people whenever there's like conflict. Everyone's like, what do the Bitcoin Core developers think? Yep, cool. And then these definitions. So if you're a developer, you might know what forks are. You might know what this is. If you're not, that's totally fine. But if you look at the graphic, so a hard fork is, imagine I have like one version of history. I'm like going along, building my blockchain, and then suddenly I hit sort of that point where I was following the old rules up until now, and now I've decided to make a change in my life. I've decided that I'm going to follow some new rules. And so I switch over and I start building blocks, but I have the same most recent block as everybody else, and not everybody decided to switch. And so this is where we diverge. We decide that some people have decided they're going to continue building on this old chain, and I've decided that I'm going to continue building off of the same like history, but I'm doing my own thing now. And this is like the definition of a fork. The part that makes it a hard fork is the fact that following new rules, like if you look at the difference between hard fork and soft fork, on the bottom here you can see that the divergent part, it follows the old rules, but it violates the new rules, which means that if I wanted to go back, if I wanted to revert back into, like I'm doing my own thing, if I wanted to revert back into the original, I wouldn't be able to in a hard fork, but I would in a soft fork. Does that make sense? Because if it doesn't, you can ask your discussion TAs about it. Okay, continue. Bitcoin improvement proposals. I think we've talked about this in a previous lecture a little bit. They're basically the idea that in a block, you can store, if you want to make a change, you can propose that and let everybody know about it by writing it into, like, writing a BIP, and then, like, it's just like a little note, and you put it into your blockchain, and you publish it to everybody, and you're like, here's a proposed, like, protocol change that I want to make and I think should exist. And then you can signal support for a given BIP when you when you build a block by including a reference to that BIP in the block when you mine it. And so it's sort of like advertising for your for the BIP that you support. Okay. Any questions about BIPs really quickly? Cool. All right. Questions in general? I think that's it. Okay.